So like I said, we're going to spend a few days on Chapter 3, Section 4. So this is Part 2 of our complex numbers notes. So yeah, let's get into it. Complex numbers. So on the previous notes, we talked about taking the square root of negative numbers, correct? Using the imaginary I, we're able to take the square root of any number now, correct? Because what's the square root of negative 1? I. What's I squared?
Negative 1.
Negative 1. There we go. We also added and subtracted complex numbers. How did I add and subtract complex numbers?
Remainder. Foil.
No, not FOIL. Add and subtract. You remember how we added and subtracted complex numbers? Essentially, it was just combining like terms, right?
Oh,
If we were adding, we just jump straight to combining like terms. And then if we're subtracting, what do we have to do with that negative? Distribute it to that second set of parentheses and then combine like terms. Do you guys remember that? Okay, how did we multiply complex numbers? Someone said it earlier. If both complex numbers had a real part and an imaginary part, it was FOIL. But then we saw one where it was just the imaginary part, so we just distributed it. Right? So it's just distributive property and FOIL. Okay? So let's get into the second part of these notes. Let's talk about complex conjugates. Two complex numbers. I'm going to turn both lights off. Stay awake on me. But you can see it better with both lights off. Two complex numbers of the form a plus bi and a minus bi, where b is not equal to 0, are called complex conjugates. So those two complex numbers, what's the only difference between them?
They don't equal 0.
What's the difference between a plus bi and a minus bi?
There's a different sign.
Different sign in the middle of them, right? It's a plus bi, a minus bi. If they're of that form, where it's the same a value, same b value, but different signs, we call those complex conjugates. The product of complex conjugates is always a real number. So is there any imaginary part to it when I multiply them?
I have no idea.
No, it's a real number.
So
It's not an imaginary number.
Does that mean it's like no weird radical over it and all that stuff? Or what?
It just means there's no imaginary part. There's no plus something I.
I.
It's just a real number. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Could be a fraction without the I value. Okay? So if I multiply two complex conjugates together, it's always going to be a real number. So for example, if I have 3 plus 2i, 3 minus 2i, does everyone see how those are complex conjugates of each other? They have the same a value, same b value, one's a plus, one's a minus, right? They're complex conjugates of each other. If I multiply it, I'd use FOIL here. 3 times 3? 9. 3 times negative 2i? Negative 6i. 2i times 3i? Positive 6i. 2i times negative 2i would be negative 4i squared, right? What's I squared? Negative 1. So negative 4 times negative 1 would give me plus 4. Right? Does everyone see that? Now when I combine my like terms here, after I FOILed it out, what happens to my I values?
Cancel.
They cancel it out. That's why when I multiply complex conjugates together, it always becomes a real number, because those I values are going to cancel each other every time. Okay? So here we would just get the real number 13. Does that make sense? You can use this fact to write the quotient of two complex numbers in standard form by multiplying the numerator and denominator by the conjugate of the denominator. So if I have a quotient, what does quotient mean? Division. Okay? So if I'm dividing two complex numbers, so it's one complex number over another, for it to be in standard form, I cannot have any i's in the denominator. So I'm going to use this fact of multiplying conjugates to get the I out of the denominator. Does that make sense? By multiplying the numerator and the denominator by the conjugate of my denominator. I know I'm saying a lot of words right now. Let's see it in action with an example. Everyone okay with that? Can I move on, or are we still writing? Okay, I'll give you a little bit of time before you do the example. Okay, let's go ahead and move on. I can always come back to this slide later if I need to. So, yesterday we talked about, not yesterday, but 2 days ago, we talked about adding and subtracting complex numbers and multiplying. Did we talk about dividing? No, so let's talk about it now. Write each quotient in standard form. So like I said, for a complex number to be in standard form, I cannot have any i's in the denominator. Do I have an I in the denominator here?
Yes.
Yes, I do. So I've got to fix that. How do I make a complex number a real number? By multiplying by its? No.
By an imaginary number.
By its complex conjugate. Right?
Oh,
So, what's my denominator in this case?
negative 1 minus 2.
1 minus 2i. It's in the bottom of my fraction, right? So what would be the complex conjugate of 1 minus 2i? Huh? 1 plus 2i. Remember? For it to be a conjugate, it's got the same a value, same b value. They just have different signs in the middle, right? So for my conjugate of 1 minus 2i, I've got to have the same a value, the same b value, and I got to change the sign in the middle. So if it's 1 minus 2i, it's got to be, what did we say it was? 1 plus 2i. Does everyone see that? Whatever I do to the denominator of a fraction, I've got to do to the numerator, the top, to keep it equivalent. Because anything divided by itself is 1, right? Anything divided by itself is 1. So here I'm multiplying by 1 plus 2i over 1 plus 2i. So I'm essentially multiplying this complex number by 1. That's a special form of 1 though. Does everyone see that? So now I just got 2 FOIL problems. One in my numerator and one in my denominator. Right? So let's FOIL the top first. F stands for what on FOIL? First. What are my first terms in each set of parentheses in the top?
4.
4 and 1. So I'm doing 4 times 1. It's 4 times 1.
4.
4. 4 times 2i.
8i.
8i. 3i times 1.
3i.
3i. 3i times 2i. 6i squared. Is everyone okay with my new numerator? Everyone see how I FOILed that out? Now, we need to FOIL the denominator. What's 1 times 1? 1. O stands for what? What are my outer terms here?
1 and 2i.
1 and 2i. What's 1 times 2i?
2i.
2i. I stands for? Nope. The I on FOIL stands for? Inner. What are my inner terms?
Negative 2i and 1.
Negative 2i and 1. What's negative 2i times 1?
Negative 2i.
Negative 2i. And what does L stand for on FOIL?
Last.
What are my last terms?
Negative 2i and 2i.
Negative 2i and 2i. What does that give me?
0.
Negative 4i squared. Everyone okay with that? Now I can start combining like terms, substituting negative 1 for I squared, and simplifying this. So my numerator, do I have any sets of like terms? 8i and 3i. So what's 8i plus 3i? 11i. What's I squared? Negative 1. In the denominator, what are my like terms?
2 and negative 2.
2i and negative 2i. What do I get when I combine those?
0.
They cancel out, right? They go away. And then what is I squared? -1. Everyone okay with that next step? Any confusion so far about what I'm doing? What is 6 times -1? -6. What's -4 times -1? +4. We're almost there. Do I have any like terms in the numerator?
Yep.
What are they?
-6, 4.
4 and -6. What do I get when I combine those? -2 plus 11i over what's 1 plus 4? 5. I'll write it down here.
That's it.
Is there any more simplifying I can do in my numerator?
No.
Is there any more simplifying I can do in my denominator?
No.
Do I have any i's in my denominator anymore?
No.
No. Can I do any simplifying with the division? Like, are 2, 11, and 5 all divisible by anything? No. So is this in simplest form now?
Yes, it is.
Yes, it is. There's my answer. Everyone okay with that? Does everyone see how when I multiplied by the conjugate, it got the I out of my denominator? We okay with that? Okay. Let's move through B a little quicker. Is that okay? Can I erase A?
Yes, sir. Mr. Frankie, what do I do if people spend money on my card?
Letter B. 1 minus 4i over 2 plus 3i. What's my denominator here? 2 plus 3i. What would my complex conjugate be of that? 2 minus 3i. So I've got to multiply top and bottom by 2 minus 3i. Everyone okay with that concept? It tells me to simplify a complex number or the quotient of a complex number. I need to multiply by the conjugate of my denominator to get the I out of the denominator. So now we're foiling. Everyone okay if I start moving quick?
Please.
Everyone gonna be okay to follow along? Okay, 1 times 2. 2. 1 times -3i. -3i, -4i times 2. -8i, -4i times -3i. Plus 12i squared. And then what's I squared? -1. 12 times -1.
-12.
I'm okay if you skip writing down the -1 for I squared. Is everyone okay with me doing that?
Yeah.
-4i times -3i gave me positive 12i squared. I squared is -1, so 12 times -1 is -12. Okay with that? Okay. 2 times 2. 2 times 3, -3i. -6i. 3i times 2. 6i. 3i times -3i. -9.
I squared.
I squared. I squared is -1. -9 times -1. Positive 9. We okay?
Yeah.
So far. Okay, my like terms in the numerator. What's 2 minus 12? -10. What are my other like terms in the numerator?
-3i, -8i.
-3i, -8i. What do I get when I combine those?
Yeah, -11i.
-11i. Everyone okay with that numerator?
Squared.
Huh?
You don't have to square them?
We're not multiplying, are we?
Yeah.
We're just adding or subtracting, right? Okay, denominator. What happens with my 6i, -6i and 6i? Cancel out. What's 4 plus 9? 13. We okay there? Is there any more simplifying I can do in the numerator?
That's it.
Is there any more simplifying I can do in the denominator?
I'm sorry.
No. Can I do anything with the division? Are they all divisible by the same number? No. So is this my final answer in standard form?
Yes, it is.
Yes, it is. Questions on B? We okay? With dividing complex numbers? Yes, no, maybe so. Can I erase B and move to C? Letter C looks a little different.
Yep, one number on the denominator.
2 plus 5i over 4i. That denominator does not look like a and b, does it? It's missing its real part, right? What do you think my complex conjugate is going to be of 4i? Negative 4i. Because I could write 4i like 0 plus 4i, correct?
Yeah.
So the complex conjugate of it would be 0 minus 4i, or just negative 4i. Does that make sense?
Yes, sir.
So I'm multiplying top and bottom by what?
Negative.
Negative 4i over negative 4i. We good?
Yes.
So am I foiling here?
Yep.
Yeah.
No. I'm just distributing my negative 4i's. Right? It's like a set of parentheses there. So I would distribute into my negative 4i all the way through. So it's negative 4i times 2. Negative 8i. Negative 4i times 5i.
Negative 20i squared.
Negative 20i squared. What's I squared?
Never one.
Negative 1. Negative 20 times negative 1.
20.
Positive 20. We okay with my numerator? Okay, 4i times negative 4i. Negative 16i squared. What's I squared?
Never one.
Negative 1. Negative 16 times negative 1. 16. Okay, up top, is my numerator in standard form? What's standard form of a complex number?
A plus bi.
A plus bi. Is that a plus bi? No, so I need to flip those, right?
Go.
So it becomes what?
20 minus 8i
20 minus 8i
over 16.
over 16.
And
Is there any more simplifying I can do with my numerator?
Yep.
In my numerator?
Nope.
No. Is there any more simplifying I can do with my denominator?
Yeah.
No. But is there something I can do with division here?
Yes.
What are they all divisible by?
4.
4. So I can divide them all by 4 and reduce them down. 20 divided by 4.
5,
Negative 8i divided by 4.
2,
2i. 16 divided by 4.
4.
Is everyone okay with that? Is this now in standard form? It's all reduced. We okay with dividing complex numbers? The main point is multiply by the complex conjugate of your denominator. So you can get the I out of the denominator. Questions on example 5?
No, sir.
Can I move on? Okay. Solving quadratic equations. All right. Good stuff.
We just learned that.
So, it says solve. X squared plus 4 equals 0. X squared plus 4 equals 0. Trying to get x by itself, right?
Yeah.
Would be my first step to get x by itself on letter A.
Where root that fool.
Nope. In order to get x by itself, I've got to get the term containing x by itself.
Oh, yeah, minus 4.
So subtract 4 from both sides. So I get x squared equals
Negative
-4,
4.
right? Now, how would I get x by itself?
Square root that 4.
Take the square root of both sides. We did already learn about this, but back when we learned about this, you guys listening?
Not really.
Back when we learned about this, we hadn't talked about complex numbers, had we? So, when we learned about this, I would have said no real roots, right? Or no real solutions. Do I know about complex numbers now and how to take the square root of a negative number?
Yes, we did.
I do, so I'm actually going to have a solution here. Okay? First off, remember I've got to count for the positive and negative value when I take the square root, correct? So I've got to have that plus or minus out there. So now I'm taking the square root of -4. So I can break it up into the square root of -1 times 4, right? What's the square root of -1? I. Square root of 4?
2.
2. Have I taken the square root of everything?
Yeah.
Yep. There's my solution. My square root goes away because I took the square root of everything. So I get x equals plus or minus 2y. Does that make sense? So we're kind of combining the last two lessons. Solving using square roots, but now we have negative numbers, and we can take the square root of negative numbers now, so we get actual solutions. They're not real solutions, they're imaginary, but it's still a solution of my equation. We okay with letter A?
Technically, putting over the solutions would not be wrong.
In this case, it will be because we know about complex numbers now. Okay, letter B. 2x squared minus 11 equals negative 47. Raise your hand if you can give me my first step to get x by itself. Nathan. Very good. Add 11 to both sides. Negative 47 plus 11 would give me what? Negative 36. Please quit talking. Raise your hand if you can give me my next step to get x by itself. Kylie. Very good. Divide by 2 on both sides. Negative 36 divided by 2. Negative 18. Everyone okay if I erase A? And my last step to get x by itself. Take square root of both sides. So I get x equals plus or minus. Don't forget the plus or minus. Now I got to take the square root of negative 18. I can break negative 18 into what times what?
Negative 1 times 18.
Negative 1 times 18. Now in the previous problem, 4 was a perfect square, right?
Yeah.
So I didn't have to break it up any further because I could just take the square root of 4. Is 18 a perfect square?
No.
No, I can't take the square root of it and get a nice whole number. So, let's find the biggest perfect square that goes into 18.
4.
9.
9, right? 9 times what gives me 18?
2.
2.
I don't get that.
Get what?
That part there.
So I'm looking for the biggest perfect square that goes into 18.
16?
Because I could... 16 doesn't go into 18. 16 times 1 is 16. 16 times 2 is 32. Right? It doesn't go into it evenly. Right? I want it to go into it evenly.
Okay.
So, I can break it up into negative 1 times 9 times 2. Because I'm still keeping it equivalent, aren't I? This still equals this. But I've broken it up into things that I can take the square root of. So, what's the square root of negative 1? I. Square root of 9? 3. Is 2 a perfect square? It is not. Are there any perfect squares that go into 2 besides 1? No. So it has to stay under the radical. Is this all simplified up? Yes, it is. So my answers are positive 3i square root of 2 and negative 3i square root of 2. Any questions on those two problems? We all good? We all understand it?
All good. My hairstyles and
Okay, moving on.
He's never said something so true.
This is my last example for the day.
They're both pretty bad.
Last example of the day. Shh. Find the zeros of f of x equals 4x squared plus 20. How do I find the zeros of a function?
Plug them in as zeros.
What do you mean?
Put the x equal to 0.
Not the x equal to 0.
The 4.
Not the 4.
The y.
The 20.
Which is what in this
F
case?
of x.
F of x. Very good. If it wants me to find the zeros of a function, it wants me to take my function and set it equal to 0 and then solve for x. So 4x squared plus 20 equals 0. Now this just turns into a problem like I had on this previous slide. Right? I just have an equation here and I'm solving for x. Finding the x values when my y value is 0. So what's my first step here to get x by itself? Subtract 20. 4x squared equals what, 0 minus 20? Negative 20. Am I moving too fast for anybody? I can slow down if I need to.
You should speed up.
Trey, what's my next step to get x by itself?
I don't know.
Give me a guess. Thank you. Divide by 4 on both sides. Negative 20 divided by 4. Negative 5. Last step to get x by itself. Square root of both sides. Don't forget your plus or minus. We got to account for the positive value and the negative value. Okay, I'm taking the square root of negative 5. So I need to break up negative 5 into what times what? Negative 1 times 5. Are there any perfect squares besides one that goes into 5? So can I break up 5 any further? No. What's the square root of negative 1? I. What happens with the 5? Stays under the radical. So my two solutions, my two zeros of my function are positive I square root of 5, negative I square root of 5. If I plug these into my function, I should get 0. If I plug them in for x, I should get 0 back. Questions on example 7? With the notes combined, there were 7 examples. Can I move on to the assignment?
Yep.
All right. Pages 132 through 133, 58 through 84, evens. This looks like a lot. It's only like 14 problems. So don't be like, oh, we got like 50 problems. We don't. We got like 14. Pages 132 through 133, 58 through 84, evens. This will be due on Tuesday. That'll be November 16th on Canvas. Are there any questions about my notes before I end the recording? Quit talking unless you have a question. Are there any questions about my notes before I end the recording?